your notes. So standard deviation is how far away from the mean are you spreading out. So we're going to draw a curve that has a mean of 75. Oh, this is just almost the one I picked. And a standard deviation of 5. So you would go 3, so 80, 85, and 90. 70, 65, and 60. Okay, on this chart, if you had a mean of 75 and your standard deviation was 12, this is an 87, 99, 111, 63, 51, and 39. So let's pretend these scores were people's bowling scores or something like that. So what can we say about the first group versus the second group? The bowling scores here are more consistent. The bowling scores on this group have more spread out scores. They have people who scored pretty low and people who scored pretty high. On this one, people are closer to the average. Does that make sense? Same with the range. We talked about the range last time, the dispersion of the data. Okay, so how do we get standard deviation? This is a little bit of a complex formula here. So this means, again, the sum of all the x values, which are just the scores, x with a bar is the mean, and the n is the number of data items. Should I say it like that? Okay, we're ready. So I need the mean, so we're going to add that all up. So add and then divide by, there's 6 items. So add that up. Okay, so I got a mean of 7. Does that look right for that data? 7 averaged. Okay, so we're going to take each x value. So I'm going to make a chart. So each x value I put into the chart. So here we go. The x value 2, subtract the mean 7 is a -5. And then that would be a 25 when you square it. So that's what I'm going to do in the chart. Okay, so I'll do one more and then you can finish the chart. 3, subtract the mean 7 is -4. So squared is 16. Okay, so finish the chart. All right, so here's the chart. Now I need the total of this. I need to add those all up because that's what this means to do, the sum of all of those numbers. So I need the sum of all of those numbers. So add them up. I got 150. It's good? Okay, so filling it into the formula, we're going to do the standard deviation with, looks like an O with a hook. The sum of all of these squared was 150. The number of items we had was 6. So 150 divided by 5, and then square root it, and you get 5.48 is the standard deviation. What? Where? 150? Good? With that, where that came from? This x minus x bar? That's what I did in the chart. These are all the x minus x bar squareds. And then this was the sum of all of those. So that's just the 150 piece. The sum of all of those squares put together. Okay. The word variance, I don't know. I don't really use it a lot, but it's just the square of that. Do you remember where we were before we square rooted? So I still have it on my calculator, so if I put it back, if I square it, we were at 30. But I think it might just ask you to do it in your booklet, but I don't usually use it for anything, so.